Hi, it's Miss Chrissy from the Hickory Corner Branch Library, and today I want to talk to you about buoyancy. What's buoyancy? Well, it's an object's ability to float. Miss Andrea recently made a video about objects sinking or floating, and she mentioned the word density. Do you know what density is? Density is how tightly packed something's molecules are. So if you have an object and all of its molecules are tightly packed together, we say it's dense. But if they're spread out, it's less dense. So a dense object feels heavy, and a less dense object feels lighter. However, it's not always about the weight. Let's see this in action. I have this teeny tiny little blueberry. And when I'm holding the blueberry, it's very, very light. But when I put it in the water, it sinks down to the bottom. Then I have this heavy watermelon. And when I put the watermelon in the water, it floats. So this big heavy watermelon is floating, but the teeny tiny blueberry sunk to the bottom. Why? Well, that's density. So density is an object's mass relative to its volume, meaning this watermelon is very big. It has a large volume area. And so it has more mass in there, but it's spread out. Whereas the blueberry is very small, so its mass is densely packed, making it dense. So it sinks down to the bottom. But there's another thing at play here. It's called Archimedes' principle. Who was Archimedes? Archimedes was a philosopher and mathematician back in ancient Greece. And the king had a problem that he wanted Archimedes to solve. And Archimedes is trying to come up with a solution. He's thinking and thinking and thinking and probably getting very frustrated because it's very hard when you have a problem and you can't solve it. So he decided to do something very smart. He took a break from his problem. He decided to take a bath. And when he got in the bathtub, he discovered something. He got so excited, he jumped from the tub and ran naked shouting, "Eureka!" What did he discover? Well, that's what we call Archimedes' principle. He discovered that water can be displaced. So in this case, when I put this watermelon in here, the watermelon displaced the water. What does that mean? Let's see. Let's get the watermelon out and see what that means. Let's take the blueberry out too. Do you see the line I have here on the side of the container? There's a red line. So right now the water is about level with that line. Let's see what happens when I put the blueberry in. Oh, sinks down to the bottom again. And the water is still right around that line. Let's put the watermelon back in and see what happens to the water. Now look, it's back up above the line. So the water is being displaced, it's being pushed up. You've probably seen that happen when you get in the bathtub. You know you can't fill the bathtub all the way to the top because then when you get in, water's gonna slosh out the sides, right? Because there needs to be room for your body. Well, in here, the watermelon is displacing the water the same way you do in the bathtub. It's pushing that water up. Thankfully, I don't have the water so high that it's all splashing out. It's staying in there, but it's displacing that water. The water around it is rising and helping to push that watermelon up as well. So it's helping it to float. If an object displaces more water than it weighs, more than its own mass, it will be able to float. But if it displaces less water than its volume, like that blueberry down there, it's going to sink. So it also has to do with the density, water displacement, and what we know as Archimedes' principle.